Welcome to module 5 of data analytics course, where we are going to talk about data pre-processing. So far we have talked about NumPy that helps us working with NumPy arrays, that is very fast for an array manipulation. We also talked about pandas in much detail that helps us filtering and manipulating the data and doing a lot of wonderful stuff. Then we also talked about data visualization in much detail, where we talked about libraries like Matplotlib and Seaborn. So objective of this module is the following. So we'll be talking about how to deal with missing data. Actually, we'll not be talking about how to deal with missing data. We have already talked about this thing in the module of pandas, so we will simply skip it. I just wrote it over here because this is a part of data pre-processing, so that you just remember that this dealing with missing data is a part of data pre-processing, right? So you can deal with missing data by either deleting the whole row or imputing the statistical values that we discussed in pandas module. Then we'll talk about outliers that are usually there in the data. We'll see how to detect the outliers, and then later on how to delete those outliers. We'll also talk about encoding the data. What do we mean by encoding the data? So sometimes most of the times we have categorical variables or categorical columns there in the data. So how to deal with that kind of data? Now you may be asking that what is a categorical column. So don't worry about that. I'll be talking about that in a while. We'll be also talking about normalizing the data. So what do we mean by normalizing the data? Do we have abnormal kind of a data? So yeah, sometimes in some cases the data is, you can say, abnormal. So we need to normalize that particular column or particular data. It is also called scaling the data. So scaling the data or normalizing the data, it is the same thing. So from next video we'll start talking about the outliers. Okay, so let's start with outliers in the data. So first of all, what is an outlier? So let's go with the book definition that says an outlier is an observation, or you can say a data point, that deviates significantly from the rest of the data in dataset. What do we mean by that? So here, if you look into this picture, you can see most of the data lies near this blue line, right? But one data point is over here. This is called the outlier. Right, so there are multiple reasons of an outlier being there in the data. For example, if you have data of salaries, and maybe the salary of Elon Musk or maybe Bill Gates is an outlier with respect to an average employee, right? So an outlier can be an honest data point as well, but an outlier is usually you can say a typing mistake or some reading mistake of an instrument or something like that, right? However, whether it is an honest mistake, it is an honest data set, or whatever, these outliers usually affect the statistical calculations a lot, right? So outliers are almost always there in almost every data set, right? And they disturb the whole, you can say, predictive analysis, whether you are preparing data for machine learning or you're doing simple data analysis. It disturbs the whole data set. For example, if we compute average, right, we have some small values, but we have one outlier. That one outlier will affect the average a lot. Let me give an example here in coding. For example, here let me have some data like this. Okay, now I have this kind of data. Let me call it A. Cool. Now let me have a B data set that is the same, but only last value is, let's say, 2000, right? So this value is an outlier that is very different from rest of the values, right? Now if I'll say I want to compute the, let me run it. So if I'll compute the average for A and B both, then what it is, oh, it does not has any mean function. Okay, just a second. Okay, so let's go ahead and compute the mean manually. So we'll say sum of A divided by length of A. Simply, that's it. So this is how we can compute mean of A, or the average of A. You know how to compute the mean? We'll take sum of all the values and divide it by the number of values, right? So here let's take the mean of B. Now look, values are exactly same except this outlier in the B, right? And here we go. You see, the average is being impacted by this one outlier by this much scale. This is 2.1, this is 201.9. That is huge. So outliers usually affect the statistical calculations, statistical measures a lot. So we need to take care of outliers. So how can we take care of the outliers? So let's go ahead and start working with Titanic dataset that we had in previous module. And let's import it again. So we'll say seaborn dot load datasets, and we'll say Titanic. Okay, and then we'll say Titanic data frame. Great. So we have it over here. All right, so let's go ahead and work on this age column and remove the outliers from this age column. But before that, before we work on removing the outliers from this column, we need to take care of these missing values, right? So how can we take care of the missing values? We have already done that, so we'll simply impute the missing values with the average, right? So we'll say Titanic, actually we don't have to do that. So Titanic dot fill NA, come on, okay, so fill NA, and here we'll say, okay, fill missing values with the mean, right? And also in place true. Cool. And then we'll also say this dot is null. We'll check out, is there still any missing value? Is NULL is null dot sum, right? So run it. Great. So all the missing values are imputed. So in age column there is no missing value. So now we can implement the data. Sorry, we can implement this outlier removal techniques over here. So the outlier removal technique that we are going to use is it's called IQR, interquartile range method, right? So I'll explain it what it is. Before that, let me just visualize the data a little bit. So I'll say seaborn dot box plot, right? And here I'm just gonna plot this age column, and here is how it looks like. Let me write this age like this dot age. Great. So this is how my box plot looks like. Actually this is boxen plot. Let me go with box plot. That helps visualization, that helps me visualizing the data better. Okay, so this is the box plot, and it actually visualizes the IQR plot. So basically this first line is Q1, that is quartile 1, quartile 25. This third line is quartile 3. I'll tell you what is Q1, Q3, or quartile 1, quartile 3, so don't worry about that. This is quartile 3, and the center line is basically the median, right? Now you see this line at extreme right, this is the maximum limit. Every data point that is from the right hand side to maximum limit is outlier, and every data point that is that is at left hand side to extreme left line is also an outlier. So outlier can be at both ends, at both extreme ends. So we need to remove these outliers, right? So let's go ahead and start working on it. So first of all, we'll find out Q1, right? So how can we find out Q1? We'll say numpy, that is NP. Remember numpy? It has a method called percentile. So here we'll pass the data, that is this one, right? Copy. Let me also do one thing. Let me call this thing as data. Cool. Okay, so now here I'll pass the data, and I'll say get me 25th quartile of this data, right? And then here I'll say get me 75th quartile of the data. Okay, so now 75th quartile is basically this line, and 25th quartile is basically this line. Sorry, 75 quartile is basically this line, which is Q3, and 25 quartile is basically this line, which is Q1. Now we need to measure these lines, extreme minimum line and extreme maximum line. So how can we do that? First of all, we'll compute IQR, and this is simply the mathematical formula that is devised by the mathematicians. So that says Q3 minus Q1. So this is value of IQR. Now this is called lower bound. So let's compute lower underscore bound. So lower bound is going to be, according to the formula, Q1 which is this line, minus 1.5 of IQR, right? And let me write this thing in brackets. Cool. So this is the lower bound. So this formula actually will make this line, will compute this line. And now if I just put it over here and I say this is the upper bound, formula is going to be exactly the same, but it is going to be Q3 plus 1.5 of IQR. So this will make this upper bound. Now all I have to do is I have to remove all the points that are above this line and below this line. So for that I will simply I'll simply write a code. So I'll say cleaned underscore data equals to empty array, and then I'll say for I in data, okay, and I'll say if, or maybe I can simply go ahead and write the list comprehension operation as well. So I'll say x for x in data, and here I'll say if lower bound is less than or equal to x, and then I'll also say, and if x is less than or equal to the upper bound. Now you see, if and only if x is between lower bound and upper bound, then put it over here in the clean data set. Otherwise don't do that, right? So if I run it, and now if we look at this cleaned data set, here we go, right? So now this data set, and also if I say clean data set dot min, what is the minimum value over here? Oh, it list has, okay, sorry. So I'll say min, and I'll write, come on man, okay, so minimum value is 3 now. So over here if you see, these values are at least lesser than 3, right? And if we look at these maximum values over here, what are the maximum value do we have over here? It is max 54. Okay, so here you see now maximum value that we have is 54. Before that you can see we had maximum values 60, 70, even 80, even 90, right? So now we can see the data is removed from either sides, from extreme positive side and extreme negative side. So this is how we can take care of the outliers in the data. Now we have only dealt with this one column that is called age column. We need to work around with almost all the columns where we think that there are outliers. First of all, we need to detect the outliers, and this is the perfect method for outlier detection, right? So it also visualizes the outliers for us, and then later on all we have to do is we have to find Q1, Q2. Formula is always there, and then we can work with. Now you may be wondering that what is this 1.5? By the way, this 1.5 is, you can say, practitioners has mentioned this value, that 1.5 is usually the most optimal value. However, if you want to be lenient from either sides, you think that this extreme positive line should not be here, it should be somewhere over here, then you can increase this value. You can make it from 1.5, you can make it 2 or maybe 2.5 or something like that. Or maybe if you want to be more strict about the outliers, you want to bring this line more closer to Q3, then you'll have to reduce this value, right? So it is totally up to you guys, or maybe you can do the vice versa. It is totally up to you guys how strict you want to be towards outliers or how lenient you want to be to the outliers. So this is basically your hyperparameter with which you can play around. Rest of the formula will be the same. So this is how you can work with, you can deal with the outliers that are there in the data, and this is sort of a part of pre-processing stuff. Another important step in data pre-processing is encoding the data. Sometimes we have, actually most of the times we have categorical variables. Now first of all, let's see what are the categorical variables. Actually, if we go back over here and we look at the Titanic data frame, so here you can see in sex column we have non-numerical variables, non-numeric values, male, female. We can obviously not perform statistical analysis or any kind of data analysis over here in these categorical columns. Here we have this class column that has categorical values. Here we have who column that has categorical values. So we have most of number of columns are categorical. So we need to convert these categorical values into numerical values if we want to perform statistical analysis over here. So how can we do that? We have two methods to deal with it. One is called one-hot encoding, second is called label encoding, right? So let's get started with label encoding first, and I'll also describe what is label encoding and what is one-hot encoding with the passage of time when we will implement it. So let's go ahead and implement label encoding on this class column. So you might be wondering that how we can convert these English values, right, or any values in any other language into numerical values. So it's not difficult at all. You have to write just a few lines of code. So first of all, we'll import a new library that is called sklearn, and from sklearn we'll go to preprocessing module. It has a built-in module called label encoder, right? So here we are saying that go to sklearn library. It has a module called preprocessing, and from preprocessing we have a class called label encoder. Go ahead and get it. Cool. So now we have label encoder. So let's generate an object of encoder. Let's call it label encoder. Let's call it encoder, right? And then here what we are going to do is we'll say encoded. So we'll say encoded data equals to encoder dot fit. Do we have anything like that? So we'll say fit underscore transform, and here we'll pass the column that we want to transform. Let's say we want to transform this class column, so we'll say Titanic data frame of class, CLASS class, right? And yeah, that's about it. All we have to do is we have to create a new column over here in Titanic data frame, and we'll call it class underscore label. No, let's call it class encoded. Okay, and class encoded equals to encoded data, or perhaps you can do it directly as well. So, and after that, let's also have a look at Titanic data frame, how it looks like, right? So now steps, what we have done. So we have basically instantiated an object of label encoder over here. Then we have just fitted and transformed this column into label encoding, and then this column was stored here in this in encoded data variable. So this encoded data variable is now stored back into a new column of Titanic data frame, right? So this was the class variable, and if I scroll over here, now here you can see the new variable class encoded, right? So now so this class has three values, right? First, second, and third, right? So this zero label is assigned to first. Wherever there will be first in the column of class, you will find a corresponding zero over there in class encoded. Wherever you will find second in column class, you will find 1 in column class encoded, and wherever you will find third in column class, you will find a relevant a corresponding 2 in class encoded. So actually it encodes each categorical value, each class of categorical value, or you can say it encodes each category into 1 digit. So this is how our categorical column is now converted into a numerical column. And you know, the rule of encoding says that encoding scheme should be such scheme in which you can also decode your encoding as well. So yeah, we can surely decode as well. We know this 2 is corresponding to third, we know this 0 is corresponding to first, so it also fulfills the rule of encoding as well. So this is how you can perform label encoding. Cool, in which each value can correspond to each category. Now if you have a lot of categories in your column, then you should go ahead with label encoding, right? For example, here if we talk about this embarked town, we have a lot of towns over here, so we should go with label encoding. right? Because it only adds one column over here. But if we have very few values in the column, for example, very few categories in the column, for example, this sex column, we have only two categories, male and female, right? So we can go ahead and work with one hot encoding. Now, how one hot encoding works? So we have pandas with us, right? We already have it. So we'll say one hot okay, so we'll say Titanic data frame underscore, let's call it one hot. Okay, so this will be a new data set that will be made. So we'll say pd dot get dummies, right? This is a function that is available in pandas. So here we'll say I want to perform one hot encoding on Titanic dataset, and on which columns do I want to perform it. So I'll say my columns would be, I only want to perform it on this sex column, right? And I also want to have a prefix, not prefix separator, but only prefix, and this prefix is going to be, this prefix is going to be sex, right? Let me also explain what is this prefix in a while. And after that, I'll say Titanic data frame one hot, also print it out. So we have created a new data frame out of this Titanic data frame, and now actually we wanted to perform one hot encoding, and you can see that this sex column is deleted from here because we have created two more columns in place of one sex column. Sex column was basically the categorical column. Now here these two columns are numerical columns. Now how it works? Basically here you can see the prefix that we set. This prefix will be added before every category of the column. We had only two categories in sex column, that is the female and male. So it looks like sex underscore female and sex underscore male. And wherever in the column the value for wherever in the column the passenger was female, you can see it is 1 over here in the female column, and wherever in the row passenger was male, you can see the 1 over here in the male column, and so on and so forth. Now you can understand, if we had a lot of categories in the sex column or in any other column, it would make as many new columns as many categories are there in the original column, right? So it is a good it is a good heuristic to follow, that whenever we have a lot of categories in the column and we want to perform encoding on it, we should go with label encoder, right? Because it only generates one more column. On the other hand, if we have a very few categories in the column, then we should go for one hot encoding. I hope you guys understand the concept of one hot overall encoding, and you guys have also understood the concept of the difference between one hot encoding and the label encoding. And finally, the part of data preprocessing is normalizing the data, right? So what do we mean by normalizing the data? Actually, sometimes the data has different ranges or scales that can affect the data analysis in many ways. For example, if let's say we have age and salary column, we have these two columns in the data, right? Now the range of age is what? Starting from 0 to at max 100, or let's make it 150. That's it. Whereas the salary can start from maybe $2,000 and it goes up to hundreds and thousands of dollars. Now when we'll start performing data analysis, or we will perform predictive analysis, since the range of salary column is so huge, so it will have much more impact on let's say machine learning model or any kind of analysis as compared to age column, because age column has has very small data range as respect to the salary column. Okay, so that is a problem. What is the solution? Solution is data normalization. What do we do in data normalization? We actually scale the whole data into one scale. What do we mean by that? Which means that let's say we assume that the maximum value there that is present in the data is 1, and we scale whole data according to that. I know this thing is a little bit unclear for now, so let me do that in Python. Overall, this process is also called min-max scaling, and here is the mathematical formula for min-max scaling that we are going to implement in Python, right? So let's do that over here, and just for the sake of understanding, let's create a dummy data, right? So let's say I have 10, 20, 30, 40 and 50. I have this data, right? And I'm going to work on it. So first of all, I need to have minimum value, right? And how can I get the minimum value? I'll say min of data, right? And I also need the maximum value, so I'll say max, and here I also say max, right? So I have these two values now, and then I need the range. Actually, I need data range. Let's call it data range because range is the keyword. We cannot use that. So range says maximum value minus minimum value, right? So now we have range as well, and here let's create a normalized data variable that is an empty list. So I'll say for I, or let's say for value in data. Cool. Now we need to have normalized value, right? So we are going to actually iterate over each and every value over here. Cool. So here we are gonna say value, right? Each value minus the minimum value divided by data range. That's it. And simply we are gonna say normalized data dot append, and guess what? We're gonna append it with normalized value. That's it. And we're gonna print out normalized data. So previously we had this data, and now here we're gonna print out the normalized data. Run it. So here we go. So you can see this 50 has become 1, right? So maximum value will become 1, and the minimum value in the data, whatever the data is, it will become 0, and rest of the values will be scaled according to the minimum and maximum value. Now does not matter if we have age and salaries, right? We can scale both of the columns according to min max scalar, and both of the columns will be scaled. Now there will be, since the maximum value in age and salary, both of the columns is going to be 1, the minimum value in both of the column age and salary is going to be 0, which means that there will be no issue of data abnormality, which ultimately means that there will be no dominance of one column over the other column. Now let's implement this thing in, actually let me just copy this, and here we go. Okay, so now what if I want to perform this data normalization on some practical data? So I'll say Titanic data again, Titanic data frame, and let's perform it on age column, right? So if I run it, here we go. So now you can see all the values of age are scaled between 0 and 1. Whatever was the maximum age has become 1 now, and whatever was the minimum age has become 0, right? And rest of all the values are scaled between 1 and 0. And same goes out for all of the let's say fair column or any other numerical column, right? So this is how we can perform a data normalization, and this formula is already available. And this, by the way, this method is called min-max scalar. And one more thing, we wrote this code from scratch by using vanilla Python, right? You can also perform this min-max scaling by using built-in methods that are available in Python. So this is going to be your assignment. You have to discover how we can perform min-max scaling by using built-in methods of Python. I can give you a hint. You can use sklearn library for this purpose, right? So that's about it for data pre-processing, in which we talked about how to deal with the outliers, how to encode the data, and how to perform data normalization.